So we're live. Youri, what's up, man? How's it going?
All good, and you?
Good, man. Yeah, just happy. It's Friday. It's been a long week, but really excited to have this conversation with you. I know I came across your profile probably like 4 weeks ago. And I'm like, I definitely want to learn more about what it is that you do with regards to operation management and operation research and also AI. So for those who don't know, can you introduce yourself?
Of course, of course. So, hi everybody. My name is Youri Moskovic. I'm from Belgium. I grew up there until I was 18, and then moved to London straight after that. And I have a background in mathematics and operations research. Operations research is basically optimization, to put it simply. And then I've started a career in AI, so artificial intelligence. More on the business side than the technical side myself, but I've been working with a lot of developers and so forth.
Interesting. So you're in London right now, yeah?
I am, yes.
Nice. I like London, man. London is a beautiful city. People say it's gloomy, depressing, whatever. I really like it.
Well, right now is a little bit weird. It's a bit of a ghost town, to be honest, because everything is kind of closed. So it's quite sad. But today's beautiful. It's blue, bright. So hopefully things will reopen soon, and the city will be alive again.
Yeah, for sure. I doubt that it's gonna happen soon, but I hope so. And yeah, everywhere is a ghost town these days. Even in Toronto, downtown used to be bustling, busy, and now it's just empty. No one is around. But anyways, so you said you did operations research, and now you're in AI, but more on the business side. So can you tell us a little about your journey through math and management and finance, and why did you decide to go into operations research? For me, operations research is really closely related to industrial engineering, so I'm very interested to know your experience in that area as well.
Of course. So I guess when I left school in Belgium, I wasn't entirely sure what I wanted to do. And I guess something that's not on my LinkedIn profile or anything like that is that I started at the University of Birmingham doing accounting and finance. But I realized halfway through that it wasn't really for me. So something that I really liked while I was at school was mathematics. And so I went to London the year after and started mathematics at the King's College of London. And I really liked it. I guess there are two types of people doing mathematics: the people that get it straight away, and then the people like me that needs to study quite hard. And so I liked applicable mathematics, but everything that was around algebra and all of the abstract parts of this domain was more difficult for me. And so when I was sort of finishing my degree, I was really considering a lot of different options. I wasn't really sure whether I wanted to start straight away, my career, or whether I wanted to do a master's. And then very close to the end of my degree, I came across this big data topic that I was completely clueless about, to be honest. And then I think this is where everything started for me. I really realized that there was, a very practical way to use mathematics and in the industry. And so from that point on, I decided that I wanted to specialize within operations research, simply because OR is, in a way, the use of mathematics to develop models that are, mathematical models that are the representation of a business, and that you can play with to work out certain scenario and make an optimal decision. And so I really liked that and decided to go for operations research then.
Interesting. Yeah, and for those who are listening, operations research, and you can also correct me if I'm wrong here, but operations research, is really a field that first emerged within industrial engineering. And like you said, you have a certain problem with a certain levels of constraint, and what you want to do is come up with the optimal solution to that. So, for example, if you have 10 different routes that you can take to get to a certain place. There's this famous example of, okay, let's find the shortest and most optimal path to get there. That would be like the travelers, the journey or travelers.
The traveling salesman problem.
Yeah, salesman problem, exactly. So that's what operations research really is. And in the context of what you're doing, Youri, I know that you work with a lot of products and you develop solutions. So you're a product person as well. So how does OR and your experience in mathematics tie in to your work with product development?
Okay. So when I was actually studying, I wanted to find a company that was doing OR and actually developing solutions for companies in the industry, because that's what I was learning and I wanted to find out. Quite interestingly, it's my girlfriend that heard about Setalia, which is the company I work for up until now. And these guys were doing exactly that, developing bespoke systems for very large enterprise and bringing it to market. And so I joined them. I emailed the CEO, I joined them. And then what's super cool about it is we're developing bespoke systems using operations research, so developing mathematical models to solve specific problems like you mentioned, one of which could be last mile delivery and basically finding the shortest path from A to B, or another one would be creating optimal set of teams to supply projects. This is one of the projects we've done for PwC, for example. But obviously, the model itself is one part of the solution you're building, because it's very complex, it's very technical. And then if you'd like to bring it to people that I guess have their daily job is to actually schedule those people to work or anything like that, you need to develop a product on top of it. It cannot just be the technology. And so this is where I guess I sit, which is at the intermediate between developing the technology, the product itself, and the design, because you need to make sure that you're taking into account the requests of the potential user, which is sort of the client of your client, and the request will be the constraints. And so that is the purely technical part. But then there's also, from a visual and product perspective, you need to ensure that they have the best user journey as possible. So this is where we're merging both, and this is a lot of fun.
That's interesting. So you are basically the bridge between the technical team as well as the customers, right? You're kind of getting requirements and definitions of what a product should be, and then communicating that with the technical team as well, because you said you're more on the business front rather than the technical front. Yeah,
exactly. So I guess a typical project for us would be getting in touch with a client that has a problem, they're facing a certain challenge. We have this sort of consultancy part of our job, which is to meet with them, ask a lot of questions to really understand the problem from all angles, and really get the overall picture of the challenge they are facing. And with that information, translating all of the problems, the pain points, into constraints that our technical team will then understand and be able to work on a specific model, and vice versa, because whenever we've got an issue or something that's not working from a technical perspective, we need to be able to articulate it in a language that your client will understand, because they're not specifically technical people. And so, as you said, it's being at the intermediate between both sides. That's quite exciting. And I guess you've got, as I said, the technical constraints, and so the pain points, the challenges of the client, which could come from the management. And then you have the actual potential users. And that might be two different sets of people. And so this is where the product comes in as well. Being able to interview those people, understand what their daily, what's their day, what do they do, how they perform certain tasks, to really understand how we can design a product on top of the technology that we're building.
Right. Okay, that makes sense. So from what I'm understanding, this is basically product development, right? and you're a product developer. And what I was curious to know is, how does AI really fit into all of this here?
That's a well, whenever you have a problem, and let's take an exact example. We worked with PwC, for example. They have a lot of people that they need to staff on a specific project. So you can look at it from a supply and demand. The supply would be the staff, and the demand would be the projects that they have. And PwC has a lot of rules that they need to satisfy on a daily basis. An example would be an employee cannot work more than 60 hours. If I have a bank account with HSBC, I cannot work on a project with HSBC. I cannot be scheduled on such a project. Employees, for example, have preferences. They don't want to work on Saturdays and Sundays, but some might want not to work during the week, for example, because they need to pick up their kids at school. That could be an example. And all of those rules need to be satisfied one way or another. Mm-hmm. And so where the technology and I guess artificial intelligence, and we can dive into what is AI maybe a little bit later, the technology that we're building is a technology that will satisfy those rules and that will be able to adapt based on some rule changes. So, if tomorrow I tell you, instead of employees working a maximum of 60 hours a week, now we boost it to 70, or we actually reduce it to 40, then our system will then be able to adapt based on that change of requests, if you see what I mean. And so the technology that we're developing is only smart if it's able to adapt based on the input that it receives. Mm-hmm. And this is where we're trying to specialize.
Interesting. Okay, so for those who are listening, right, what would you personally define as AI? Because it is, an up and coming field. I mean, it's been around for a long time. There was a little winter in the 80s and 90s, and then now that we have better computational power, we have more data. It's easier to leverage those sorts of algorithms. But what would you define as AI, and what is it?
Do you want the short or the long answer?
Let's go with the short one and then expand it to the long one.
Okay, perfect. So I can see AI today, I would say, has two definitions. As you said, it's becoming quite like a buzzword in the industry, and so everybody is doing AI. But I guess I might be here just to tell you that it's not really true. I think there are two real definitions of AI. There's a weak one, which is getting a technology to do what humans can do but better. Mm-hmm. But I actually believe that as human, we're not that good at making decisions, but we can dig into that later. And then the actual good definition, and this is Daniel, so my CEO's definition, which is a system needs to be goal-directed adaptive behavior. So it needs to have a goal in mind. So it has an objective and it's going into that direction, but it's also able to adapt based on the information that it receives. And if it receives a new set of information, it needs to be able to completely change its behavior because of that set of information. And I guess for that particular reason, I tend to think that there isn't many examples of true intelligent system in the industry anywhere. Even the stuff that we're developing, we could argue that it's not even intelligence, it's rather automation, and we are aspiring to develop intelligent systems.
Okay, I see. Okay, so two things you said, objective and adaptiveness. I guess every system that we have these days already does have an objective, but then the part that makes it AI would be where it can adapt based on different and changing circumstances and constraints.
Exactly. I mean, the way we can see it is it is a system that has 3 to 4 steps. The first step is getting the data, which is obviously the first part. You absolutely need that. And then from that data, you can do certain things like analyzing it, understanding the different trends, the patterns in the data. And so this is called predictive analytics, and this is, within the field of machine learning, data science. And then with that piece of information, you can take some action. You can make a decision, and this is the field of so operations research, prescriptive analytics. And I guess most of the systems in the industry right now have those three categories. But this fourth component, which is the adaptiveness, is what's making it truly intelligent. Mm-hmm. If, for example, tomorrow you give it a completely new set of data to a system, it's very likely that the system will crash because it won't know what to do with it. And I guess an example would be, imagine you are in a self-driving car and your brakes don't work for some reason. And in front of you, you've got three options. You have literally a mom with a small baby, you have a very famous doctor, and then you have a cliff. And you can't control the car is driving itself. What should the car do? And I guess that today, the car can't take that decision, really. And this is really very important nowadays to try and be able to answer that specifically, because tomorrow when you'll have hundreds of thousands or millions of self-driving cars, you'll need to find a way to actually adapt to that kind of situation and be able to answer like what's good and what's bad. And so that's really why when a system today makes a mistake, you take it out of production, you make some tweaks, you adjust it, and then you put it back in production. So it's not truly adaptive by itself. There is still a lot of human, there's like still this human component that's embedded into the whole, the whole journey. Sorry, but that's that's sort of how I see it.
Interesting. Yeah, you mentioned some good points around like the taxonomy and the breakdown of different sorts of calculations. You mentioned predictive, and then there was prescriptive, right? But then the point where AI actually becomes very useful in leveraging for different solutions is when you can create adaptive systems, right?
Yeah.
From your perspective and experience, what do you think is the biggest challenge to companies actually leveraging AI? Is it the fact that they don't have a lot of knowledge about AI, or is it because from my experience, I noticed a lot of companies don't have structured data. They don't have a proper data collection process to have in the first place, so they can analyze it and then leverage AI. What do you think is the biggest challenge right now?
I think, as you said, the biggest challenge is the data, because this is really the first step in the AI stack that we talked about. If there's this famous saying like garbage in, garbage out, you can develop the most intelligent system in the world. If the data that you input into it is bad, that means, you have poor quality data, poor quantity, you won't get the answer you're looking for.
Yeah.
And obviously, today, building bespoke AI systems is quite costly. And so only very few companies can really get to a level where they can sort of buy or just invest in that type of technology. So if we're looking at very large businesses, very large enterprise, these businesses are usually not the best at collecting the data from that they're generating. Mm-hmm. And simply because they've been around for so many years that it's a challenge. It's definitely something that can be solved, but it requires a lot of work. And I guess my hope is that there is obviously a new emerging companies like digital native brands, e-commerce, and other types of companies where the data they generate is in a much better shape, much better quality, because they work with systems like Shopify, and they do their marketing on Facebook and Google. And so being able to get access to that information very early on is something that's very valuable to develop these intelligence systems.
Yeah, for sure. I agree. It's that's the first step, making sure that you not only are collecting data, you're collecting the right data, and then how are you structuring it? How are you architecturing? Because you can't just analyze any sort of data that they give you. Like you said, garbage in, garbage out. If it's not structured, if it's not of high integrity, then you wouldn't be able to trust the output that you get down the road, right?
Exactly. I mean, you would need to have the data that comes in needs to come in a certain format that's sort of agreed with the company you're working with, for example. And you know, if it's not coming from a database and it's coming from an Excel sheet that's being updated manually every week, the chances are that you know your system will crash, because you only need a comma where you know you were not expecting it, and you know it's not running, it's crashing. So this is really the first step. And I guess a lot of companies today are catching up, like they really understand the importance of collecting the data in the right shape, in the right format. And so they are investing a lot to create databases and centralizing all the information they generate. There's still a long way to get there, but at least companies now understand that, which is really good.
For sure. You mentioned something earlier. You said that humans are not good at making decisions. Can you expand on that a little?
Yes. So I guess there's two parts. I can't remember the guy who said it. I think it's Daniel Pink. Essentially, this author, and I think is a psychologist, he argues that we've got
is
two
he the
parts.
author of Thinking Fast and Slow?
Exactly.
Okay.
Yes. Is it Dan Pink? Is that?
I think so. There were two authors who wrote it together. One of them should have been Daniel Pinkman or something like that. Yeah.
I'm Googling it. I think it's him. It's Dan Pink. And he's arguing that we've got two parts in our brain. There's one that's very fast and sort of so irrational kind of, and then there's a slower, more purposeful part of our brain that we kind of use to make more complex decisions. Mm-hmm. And I don't have any slides or anything here, but he says that basically we're not very good with that part of our brain, the one that's very slow, because we can make, you know, very fast decisions like this with a set of information that we've got, and we are very we can be influenced very, very, very rapidly. An example he was giving actually is if you're at, there's been a study where teachers from a certain university were holding a pen in their mouth while grading a paper. And while they were putting the pen, you know, like this, they were frowning, and they were more. They tended to give a more negative score rather than when they were having it like this. When they were smiling, and they were, you know, they were more likely to give better scores. So on that hand, we're very we can be influenced very, very fast, and so not very good at making those types of decisions. And then, you know, when it comes to making more complex decisions, this is where operational research comes in, because our brain is sort of limited to a certain point. That means, let's say I give you an exercise, which is I have 5 employees sitting next to each other. And then you want to give these 5 employees a task each. How many ways do you think there are? How many possible ways we can allocate these people to those tasks?
I would say like 25. Is it 25?
It's so it's 5 factorial. So you have 120 ways of actually giving, you know, the tasks to those people. And then you add 10 people to the mix. That's 15, and then you have 50 tasks, and you'd like
it grows exponentially, right? The more
it grows exponentially, exactly. Right. And so you have more than, you know, 1 trillion different options all of a sudden. And then when you work with companies like PwC, for example, where they have thousands of employees that you need to allocate to hundreds of projects, you quickly understand that the human brain is limited, and it's not to any fault of, you know, it's not our fault, it's just the way we are. Yeah. And so we sort of need to be helped in a way, which dedicated and bespoke algorithms that are designed to go to be faster at computing certain calculations.
Right. So you mentioned a couple of points there. I want to dig into a couple of them. So one thing is generalized AI, and another thing is basically specialized AI, right? And let's say for specific problems where computers are much better at calculating than us, and these calculators have been around for a very long time, even since the 80s, 70s. There were some things that humans couldn't do that machines could. But then when we're talking about generalized AI, I wanted to get your thoughts on when you think this singularity that Elon Musk is talking about happens. Because in the beginning it was like 2040, and now he's saying like 2025 this is going to happen, and I'm like, oh wow, what's happening? Like, what do you think about that?
I thought he was even saying that we are already in a simulation.
Well,
I think
he did say we're already in a simulation, but he said that the point of singularity where AI is going to overtake a human in terms of tasks and thinking and maneuvering around different problems is going to be around 2025.
Yeah. Well, I think it's very hard to come up with a date, like a range, a time frame. But I think today the type of systems that we're building is really scratching the surface, because the systems that I've been talking about for PwC or Tesco, the traveling salesman problem that we're solving for bigger companies, they're sort of very good at one specific task, not a range of tasks yet.
Exactly, yeah.
And so you have these systems that can do staff scheduling extremely well, or you have these systems that can optimize the journey from A to B to minimize the amount of time or the amount of kilometers or miles that you're doing. But I guess the next wave would be for these systems to own a certain industry or certain sectors, and so a set of tasks. Let's take transportation as an example, and you'll have a system that will be able to coordinate. I'm sort of thinking out loud, but coordinate taking you from your home, bringing you to the airport, actually piloting the plane you're flying, and then taking you from the airport where you landed to another place, a hotel or something like that, without having any human interaction. I'm guessing this will actually happen, but putting a date into it is very, very complicated. And then what Elon Musk is talking about is singularity, is really like when AI dominates everything that we do. And so they start controlling humans, I guess, in a way, because they are more intelligent in every industry, in every sector we're involved in. And this, to me, could happen, but I think we're very far from it.
Very far from it.
Who am I to say that Musk is wrong? I don't know.
Yeah, I mean, look, it's you're also in the field, so you definitely have some opinions. Now, it is scary though. He always says if you can't beat them, then join them. So that's why he's also making that neural link. So eventually we become, what do you call it? We become kind of AI sentience as well,
I see. Yeah, but honestly, there's something quite interesting about what he's doing with Tesla. I've been reading about his sort of master plan that, Tesla will become self-driving cars, and they will be able to take you anywhere. And what this means is he's essentially building a centralized operation, because he's doing software and he's doing hardware. And so everybody that has a Tesla today, they have an app and they can call their car, they come out of the garage, for example. But what this means is that in the next few years, people could say, for example, that they're not driving their Tesla at the moment. And if you are on a Tesla app and you don't own a car, you could perhaps book one to come and pick you up, just like you have an Uber today. Mm-hmm. So you could potentially think that what he's up to is essentially putting millions of Teslas out there, and then having people, consumers, that downloading a certain app and calling a Tesla just like you're calling a taxi today. and they come, they pick you up, they drive you anywhere you want, and then the Tesla comes back home, sort of. And the owner of the Tesla can earn, royalties on that, for example.
Yeah.
So you won't, and I think this is quite interesting because, oh, sorry, the line was cutting. Go ahead.
No. Go ahead. I'm listening.
I was saying that it's quite interesting because what I was saying about transportation, which is the whole industry, I mean, it's kind of getting there, right? Like the Tesla will be able to take you anywhere, and let's say to the airport, and then, he's now working on Falcon X and all that stuff. And yeah, I don't know. He's getting there for sure.
It's crazy. I was watching one of his interviews with this organization in Germany. It was a very recent interview. He mentioned that he wants to take his operations to Berlin as well and create a factory there. I forgot the name of the interview. It was with Axel something. And anyways, over there, they were talking about all of these accomplishments. And to your point, slowly he's taking over very major industries. So another point that's important as we move forward is how to set up policies around privacy and security and all of these things, right? Because the old system is not going to sustain this new approach that we have.
Yeah, I mean, totally. I feel that we can see that with social media companies today, or just the big tech firms. They're dominating the world in a way, and they've become too strong for governments to sort of stop them. Now, I'm sure that one way or another, the government will find a way to either break them up or make them pay more taxes or things like that. But they are so advanced compared to, governments just in general, in my opinion, that they become even more influential. And that's in a way is a danger to society, but it's also, the way people have sort of decided to live, and then the sort of technology they decided to embed. So it's definitely an interesting space. And a lot of things, I feel that a lot of things will happen in the next 5 years. We can see that in Europe, in the US, everywhere.
For sure. And yeah, to your point, I mean, governments, they're becoming less and less influential anyways. Seems like these guys are being the new governments now. You have Facebook and Amazon and Tesla and Google. These guys are really the new power,
Yeah, I guess. I think the government is still strong, and they will find a way to sort of collaborate with these guys.
Yeah.
But definitely they've amassed a huge amount of power, and it will be interesting to watch the space, how things are growing.
For sure. We we did go on a tangent there, which was interesting tangent. I want to kind of take us back to the work that you do, just to zoom in on something you mentioned earlier. You said that you're not necessarily a technical person, but you're obviously operating within this field very well. So for those who want to get into fields such as product development with a touch of a tech, so product development within the tech industry, how much is it crucial for them to know how to, let's say, code and be very technical, or is this not necessarily something important?
It's a very good question. I mean, my experience has been, I personally learned how to code as I was at Setalia, simply because I wanted to know more about the field I was into, and being able to speak the same language as the data scientists, for example, or the operations researchers. I think you don't specifically need to know how to code, but you certainly need to understand the theory, which means you need to understand the domain itself, how things work, how you need to create a machine learning model, for example. What are the different components? Same thing goes for operations research. What does it take to build a mathematical model that will make a decision, for example? Because one way or another, I guess I don't see myself as a manager, because I don't consider myself on top of the coders and the technical people. I kind of see myself as the intermediate and transmitting information and being able to speak two languages, the business and the technical one. But in the end, when I'm with the technical team, I sometimes don't have the final answer, to things. And so I guess my goal is to be able to connect the dots and to make sure that you're surrounded with people that have a good understanding of what's going on. And so, when we need to make specific decisions, you have a decision maker for that particular field you're into. If it's software engineer, you've got a very strong software engineer, a senior software engineer that can, make the call. If you're working on an operations research model, you have a strong optimizer that can make the call with you. So I think it's definitely a plus if you know how to code and if you have specialty in certain field, but I don't think it's a necessity, because in the end, what you need to be able to do really well is being better at with your soft skills than your hard skills when you're in the situation I am in. But there's this T-shaped thing that we like to show. You need to be an expert in a certain area, but you need to be able to have an oversight of everything that's going on in the company. And so the more knowledge you have about whatever is going on, the better. And you even have people, that are becoming pie-shaped. So you have the two expertise, and then you have an understanding of everything that's going on in the rest of the company. And so I'll say it's not a must, but it's a nice to have.
Interesting. I did enjoy that pie shape example that you gave, for sure. That's interesting. So you're right. In a sense, someone in your position, the soft skills are very important in terms of communicating with both fronts, the business front and the technical front, and certainly does help a lot if you know about the technical front as well, right? You'll communicate better.
Yeah, and I guess communication is one of the most important aspects of my job, and you quickly realize that talking to a client is completely different than talking to a set of engineers, for example. So being able to adapt your communication process, the way you approach people, the way you talk to them, is an extremely important part of the job.
100%. We're around the 40-minute mark, Youri. If there's anything else that you wanted to talk about, I'd be happy to hear. And if not, it's been really nice talking and getting your insight about some of the things that you do.
I mean, it's up to you. I'm happy to talk about any topics if you want a little bit more, or we can leave it here. Up to you.
Yeah, no, 100%. Let's leave it. I want to make sure the conversation is fruitful. So I have more questions, but I'm gonna have to ask them later on, because if we get in, we're gonna get into another 40-minute conversation, and this is good. 40 minutes is nice. It's a nice sweet spot,
Perfect.
Well,
perfect.
Thanks a lot for hopping on. I know you're busy as well, and it's a Friday, but really appreciate it. It was a good conversation.
Well, it was a pleasure. Thank you very much, and have a good weekend.
Thank you, man. You too.